Hey guys, welcome back to my channel. Today we're gonna move on to the new topic of the trees, which is breadth first search. Until yesterday, we have looked at um, the depth first search and its implementations. Well, breadth first search is quite similar um, in a sense that it works on trees, but contrary to depth first search, where it goes down the depth first and then move on to the next node. Breadth first search actually searches the certain depth, so the level, so starting from the root and then to the level, and then after it searches all the nodes through that level, it moves on to the next level. So that's how it works. One second. Uh, yeah. So, um, yeah, where was I? Breadth first search. Yeah. So, one difference between depth first search and breadth first search is that to implement depth first search, you have to use recursive approach on stack, whereas in breadth first search, you use a queue data structure instead, and you do it iteratively. So how you do it is basically, let me share my screen. Yeah, so given this data structure, given this tree, you initialize a queue, and now you start from the root node. Well, it starts with five, so we just put five into this empty queue. Um, and then we have to keep track of its length. So currently the length is one, so we put one here, and we have to iterate this amount of time. So since it's one, we iterate once and find its children's node, find its children node, which is three and two, right? So we remove this five and then put three and um, two into it. Now this level is completely done, so we move on to the next level, um, and we start with three. Um, now the length is two, right? So we keep this length as two. So this means that we have to iterate the function two times. We start with three. The child node of three is four. So it means that we have to remove this three first. So we're removing elements from the leftmost side, right? And then when we're putting a child node, we're putting on the right side, which is um, equivalent to the um, definition of Q LIFO, right? A FIFO, first first in, first out. So um, four goes to the right side, so there's now two four. But now we also have to iterate two times, so we go on to remove this two as well. It's gone. And for a children node of two, there are one and three, one and seven, right? So we append to the right side one and seven. And now you can see from this tree that when n is two, so the second level, 417 is the level that we're looking at. So by constantly doing this process, we're searching through each level and then moving on to the next and next and next until there's no children node. So that will be the next level when n is 3, the level is 3, and yeah, this part is leave, this part is leave, this part is also leave. So yeah, that's a basic implementation. So the theory behind the code. Now we're going to try to put it into a code, how it works. Mm, Python file. So now let's say that there's this function. So this is a basic template of doing BFS. So Q equals dq root. So that's the first the root node. When it starts with root node, we just remove it and then move on to its children node, right? Now, while there's Q nodes in current level equals to the length of Q. So that's the amount of times we iterate. Then now for in range nodes in current level. So within this range, we're gonna put the children node. So that will be not put the children node. We're gonna remove the leftmost side. So we're gonna pop the node, right, from the leftmost side. So that will be node equals Q pop left, and we print out this value. Now, if node left, then we put the next level into the queue. So that would be Q appends node left. If node right, then Q append node right. Right, so that's the basic template for this BFS. Now let's try to solve a question with it. This one is a medium question, so binary tree right side view. The what it wants is pretty simple, as all question is, but this one is particularly simple. So you just see the right side, rightmost side of each level, and then you have to return it as an output. Yeah, so you have to return the value of the node. You can see ordered from top to bottom, so 1, 3, 4 in this case. So from what we defined, from what we have tried to solve the basic BFS, when we go back to the template, if we want to just return the rightmost side of the of each level, it means that when we are iterating each level within its length, of course, we have to save the rightmost side in some kind of array, right? And yeah, that will be pretty simple because we just have to save the last element, last node of its children when we are trying to add it to the queue. So how will we do that? I think the best way is to just copy paste the templates first, and then from there we can add uh, what we have to do. I'll just, yeah. So this has to be indented, I guess. Right. So like I said, we have to store the last element of each level, right? When we're iteratively um, adding it to the right side. So let's put that as answer. So that would be ans equals empty list. For this underscore is just, we're just going through all the elements. We're not caring about how many times it's going through. When it gets exhausted, then it's gonna disappear. Node equals q pop left print. Now we have to add some to show that we are adding the rightmost node for the current level. So that would be while q node in current level length q and append q last element. Nope, nope. Top val. Right? This makes sense. Okay. And also we have to add the edge case. So if not root, if the root is not, if the root is empty, then we return, yeah, because I think case 3 is empty. Let's try this and see if it works. Okay, so DQ is not, maybe spelling mistake. Okay, wrong answer. It's just returning the empty list. So probably here it's not adding to the answer back. Well, we really didn't return the answer here. Let's check the indentation. Let's see if this works. Yeah, so that's correct. So it was pretty basic, right? So we just used the basic template for BFS, and then we just stored the last element of the right-hand side, the each level, and then put it back into the queue iteratively, right? So if we were to use DFS for this kind of question, that would be very hard. But because BFS already has this kind of template, we could easily solve it. Yeah, well, for a medium question, I think it was pretty easy. Tomorrow, maybe we're gonna look into more example of BFS, or I think we're gonna move on to the next topic within the trees. I'll have to see tomorrow, but for now, uh, this was it. Thank you guys all for listening, and if you guys have any comments, let me know in the comment section. And yeah, see you guys tomorrow.